Misleading graph. Graphs let readers analyze data easily, but are sometimes made to influence conclusion by misrepresenting the data. So what we're going to do in this lesson is we're going to look at some graphs and some data, and we're going to find where are they misleading. And then we're going to say how are they misleading? What did they do to make this a misleading graph or data? So number one, the line graph shows monthly profits of a company from October to March. Which graph suggests that the business is extremely profitable? Is this a valid conclusion, and explain? So if we look at our two graphs here, we have company 1 and company 2. We want to look to see which one looks extremely profitable. So which is the business that made the most money? Well, if we look at our two graphs, we look at graph 1, it looks like this company started down at $14,000, they went up all the way up to $15,400. But then when we look at this graph, it looks like this company just barely moved up. So when we're just looking and to see which business looked extremely profitable, we would say graph 1 did. Or the first company here. Then it says, is this valid, a valid conclusion? Well, if you look at your graphs here, we need to look to see to make sure everything is exactly the same. So when I start, I look to see they both have a break in the graph, so that's fine. Okay, we both started at 14,000, and then we went to 14,500, then 15,000. But then graph 1 started going up by $100, and graph 2 continued to go up by $500. So would we say this is a valid conclusion? No, it's not valid, because graph 1 changed the intervals from $500 to $100. So again, that looks misleading because our intervals are different. We started at 500, then we went up to 100. So if you think about your dollar amounts, changing from an increment of 500 is a bigger gap than changing from an increment of 100. Okay, so again, when you're looking at your graphs, you need to look to see, are our intervals the same? If it's a bar graph, are all the bars the same? You need to pick out what makes it look misleading. What are they trying to get your attention on? Right? And the other thing we're going to talk about is misleading statistics. So statistics can also be used to influence conclusions. All right? So the first thing we're going to do is we're going to find the mean, median, and mode of the SOFA prices shown in the table. Then we're going to figure out which measurement might be misleading in describing the average cost of the SOFA. And then we're going to explain why. Okay, so for the first step, we're going to find our mean, our median, and our mode. So again, the mean, median, and mode, whenever I go to find those, I always start by listing my numbers from least to greatest. So I'm going to look at my numbers over here on the chart, and I'm going to list them. So I have 350, 1,400, 1,400, 1,600, and 1,700. So again, I list them from least to greatest. Then now I'm going to find my different values. The mean, again, the mean is the average, so we add up all of our terms and we divide by however many we have. So we'd add them all up and we would divide by 5, and when we do that, we get 1,290. To find the median, again, a median is the middle, so I start from both sides and I work my way in. So the median is 1,400. And then the mode, again, represents the most often. So the number that shows up the most often is 1,400. Okay, so after I found my 3 different measures here, now I can answer my question. Which measurement might be misleading in describing the average cost of the SOFA? So I want to know out of these 3 values, which one is telling me it doesn't represent most of our data? So when I look at these, I would say the mean is misleading. And why I would say it is misleading is because it's only representing the lower number of our data. So if we look at our numbers, if we were to graph these, 350 would be what we call an outlier. That's one who throws our data off. You can either have a small outlier that's a least value or an outlier that has the maximum value. So we have an outlier here of 350. So that takes our median or our average down. Our mean goes down with that. So I would again say the mean because it only represents the lower values. Okay, so if you look at our mean again, 1,290, if somebody looks at that, they think, oh, these sofas are, sofa styles are actually pretty reasonable. But if you go in and look at the prices, you have 4 values that are larger than this. Okay, so you want to get the value, if it's not misleading, that represents a majority of it. The mean, again, here represents only part or one number of our values. So again, when you are finding misleading graphs and statistics, for graphs you look to see, are our increments different? Do they all look the same? What are they trying to get our attention for? And then when you're looking at your data sets, when you look at your different measurements, you need to pick out the measurement that represents only a small part of your data instead of all of it.